I guess without further ado, we'll hopefully move on. Paula, do we know what's happening with our technical issues at the minute, or are we going to come back to that and explain a bit later?
Yeah, apologies, folks. We had some slight technical difficulties, but we are frantically in the background trying to update the Twitter page and the kcduk.io website so that you've got the up-to-date YouTube link. Although I guess if you're hearing me, you must already have the link, so that's kind of confusing.
It's a very good point. Yeah, if you're seeing us, then you're clearly in the right place.
Yeah, absolutely.
So, hopefully, our next speaker is maybe ready. I know we've come to him slightly early, so perhaps he's not. We're going to have to fill, I think. Well, let's see what we can.
We could talk about one of our sponsors.
Yes, I was just thinking that. Do you want to do one of our?
Why not? Just whilst we're waiting for our next speaker, why don't I do a quick readout for Snyk, who's one of our diamond sponsors. So just a quick bit information about Snyk. They are a cloud-native application security leader. They enable 2.2 million developers to build securely with a vision to empower every modern developer in the world to develop fast and stay secure. Only Snyk provides a platform to secure all of the critical components of today's cloud-native application development, including the code, open source libraries, container infrastructure, and infrastructure as code. Snyk's developer-first approach enables technology-driven companies to scale security in today's fast-paced, digitally transforming world. Snyk's security platform is powered by its industry-leading proprietary vulnerability database maintained by the expert Snyk security research team that also powers security solutions from strategic partners such as Atlassian, Datadog, Docker, IBM Cloud, Rapid7, Red Hat, and Trend Micro. The company works with global customers of all sizes to empower developers to automatically integrate security throughout their existing workflows.
Excellent. Thank you for that, Paula. And Snyk also pay my salary. I should hold my hand up. So clearly I am horribly biased. But that's a really good timing as well, because our next speaker is I'm sure familiar to many of you in the community. Certainly familiar to me as I work with him every day. So let's bring Gareth Rushgrove onto the stage.
Yeah, hi Matt. Hi everyone.
Hi Gareth. Hey, good morning. Thank you. We've come to you a little bit early, but you know, as unsurprisingly, all the things have fallen over this morning already. But hopefully, we're getting back on track now.
No problem at all.
Right. So, shall we give Gareth the floor?
Yeah. Okay. So, good to meet everyone. I will jump into slides shortly, but just to say hi, I'm Gareth Rushgrove, VP of Product at Snyk. Also sort of, I guess, like, well, I say occasional, but it's far too much time spent hacking on open source projects for a good while now, probably most recently with Contest and Open Policy Agent, but around the Kubernetes community and Docker community and Puppet community and a bunch of others before then. So let me share my screen and we'll get started. Matt, can we see my slides?
Yes, we can.
Fantastic. So, welcome everyone. I'm going to talk about software bill of materials for cloud-native applications. But don't worry if you don't know what software bill of materials is. I'll do a bit of an introduction there. This isn't a super deep dive talk. We're not going to see loads of demos and examples and get into the weeds of this. I really want to just put this in people's heads. Get people started thinking about this space, tell you about a bunch of the interesting things that are happening, and maybe give you some homework if this is of interest to you. As mentioned, I'm Gareth Rushgrove, VP of Product at Snyk, and a whole bunch of other things when I'm not doing that, including curating the DevOps Weekly email newsletter. Ask me anytime about sending an email every Sunday for 10 years straight. It's a very strange thing to do. Okay, so what is a software bill of materials? This might be something that you've come across before. It might be something that you've never come across at all. But I don't think it's something that will be fundamentally unfamiliar when you sort of work out what it is. But here's a description that I think sort of sums it up really. It's a complete, formally structured list of components, libraries, and modules that are required to build a given piece of software, and the supply chain relationships between them. So fundamentally, it's a list of ingredients. It's the list of ingredients for a bit of software. And it's not just the how we build it instructions. It's the what's in there in like sort of details. It's all the messy bits of how are they connected. But why is this interesting? Why is this something that maybe isn't just part of how we work already? And why is it interesting now in particular? There are a number of different use cases for like having a list of all the software in all your software. And I think these three sort of sum it up to a degree. Like you've got sort of intellectual property management problems. That might be compliance oriented, that might be export rules, that might be open source license issues. There's all this sort of stuff around like an audit department needing to know how everything is in order to decide what regulation and rules need to be enforced. I think if you're in a larger organization, you've probably come across some of this already. You're probably doing this already. So software bill of materials, which is really an implementation detail under the hood of that. You also might not work in a large company and you might not have come across that. But in any case, it sort of feels like a important, but hopefully someone else's problem to a degree. Probably the one that's bubbling up more and more recently is software supply chain security. That we're much more conscious today than maybe when a lot of the technology we use was built and designed, that there are risks inherent in how we build software. Open source is undeniably good at many different things, but it absolutely means that the number of contributors to the piece of software that you're producing is a lot greater than you can probably reasonably fathom. You're getting software from lots of places. It's coming through various different tools, build systems, source control systems. A compromise at any one of those points potentially opens you up to an issue yourself. And we're seeing more of those attacks. We're seeing attacks on the sort of like package management infrastructure. We're seeing attacks on source code management systems. And so understanding what goes into your software is the first step, arguably, to being able to maybe reduce the risk, maybe manage some of those vulnerabilities and understand them. End of life, like when is something in your chain actually no longer maintained? And there are also just requirements around high assurance systems. Like not everyone is going to be working in a sort of high security, high threat environment. But at some point, those environments were very niche. They were very much in the sort of government, military, industrial sort of complex. Today, that's less true. And what is critical infrastructure is a good academic debate, but it's becoming broader than taking down like the internet, taking down mobile phone signals. Like those things are life impacting at this point in a way that maybe they weren't 20 years ago. So software supply chain security, I think there are multiple aspects to it, but fundamentally understanding what is in the software we're shipping, I think is part of it. And last but not least, I think there are a number of interesting use cases just around asset management. That title, I'm not sure about because it sounds boring. I don't think it is. I think there's all sorts of interesting use cases that if we knew what software we were running, we could actually like come up with and solve. And just research around usability and usage is interesting. Process improvements. Like, why is this organization using 103 different versions of OpenSSL is probably a good question, but not one we're even capable of knowing the answer to the number of things we're using today in lots of cases. So search and visibility built on top of good software bill of materials infrastructure, I think is in the future, but I think powerful for a number of different problems. But why now? Because this doesn't feel like a sort of a problem that is brand new. And yes, maybe the security stuff is more in the news today. It's more powerful today. There are more threats today. But this doesn't feel like something that someone has just invented, and it's not. The conversations around software bill of materials date back, and probably from the start of really software being composed of multiple parts. But I would say those conversations have mainly been within some areas around. There've either been implementation details of other tools, like some of the ones that I work on at Sneak. There have been conversations in like sort of strange corners of FOSDEM about license compliance that I hang around with. There have been standards bodies or people very close to governments that scale problems. The good news is a lot of that work has laid the groundwork for us to actually be a lot further forward now than we might otherwise be. And what's really lighting a fire, I think, under a lot of those conversations and taking them from being maybe a more academic, slightly standards geeky type place that I'm happy in, to something that I think is going to become a lot more mainstream over the next 12 to 18 months. And that was an executive order by the Biden administration back in May. This mandates not just a load of sort of work on actually finishing a bunch of this standards work and publishing guidance and recommendations from the US government, but it mandates adoption of those by US government entities. Now that you might think is well, we're not in the US, you're not selling to the US, who cares? The supply chain impact of that, given the number of companies that are and who are selling into the US or selling into the US's supply chain, is actually huge. So I think the impact of this will take time, but will be felt everywhere. There's also the fact that solving this requires software, and software companies are definitely rushing to solve these problems and adopt some of these standards and practices. So I think you will see a lot more noise about this, both good and bad. I think you will see adoption of this, in some cases probably too quickly, and other cases not fast enough. But there's a lot of history and background that, if you are interested in the sort of anthropology and the sort of history here, definitely worth digging into. Shout out to the NTIA in the US, National Telecommunications and Information Administration, probably not a government agency you're super well familiar with. They don't have exciting TV programs following their agents around, as far as I know. But they've been doing some really good work, which was very much focused on a multi-stakeholder process. They weren't trying to make decisions. They weren't trying to mandate. They were trying to bring often quite opinionated people who disagreed violently together over several years, really to sort of work out some of the consistent items of what everyone cared about rather than what some people cared about. There's also a lot of work going on, and I think some of this has been going on at the same time, but a lot of it was, I think, probably accelerated. The dates sort of add up. In around sort of frameworks that we can adopt to apply some of the sort of standards that are emerging. Like these are good starting points if you really want to understand like the problem. Like I covered the problem at a very high level. These don't. They dig into the details. They like sort of basically breaking down different use cases, different threats, and how you might address them, and then coming with high-level sort of frameworks of how you might sort of measure your maturity and solve some of the problems inherent, like with supply chain security in software. So the work that mainly Google have been doing around SALSA, OWASP have the software component work. More recently, Microsoft with SCIM. The CNCF themselves have published a really good document as part of the SIG security work, so software supply chain best practices. All of these are interesting to look at. They solve different problems, different, like sort of, some of them are very recent, some of them are a bit more mature. I think combined, they're a really good starting point and introduction to this whole space, why it's important and how you might go about solving at the organizational rather than technology scale. I touched on something there as well, which was a bit more details, a bit more technical on the technology side, that there are emerging standards here to help us reason about, like, technically, okay, what is a software bill of material? Because it's fine to say it's a list of software, but you can go, well, like, okay, here's a spreadsheet, here's another spreadsheet, here's a Word document, here's a PDF, here is a text file, here's a CSV file. All of those are software bill of materials. They are all lists of the software. But not only are all of those in different file formats, they're probably all in different, like, naming conventions and version formats, and they include different bits of information. There's, like, it's fine if you want the, if you think this is a tick box exercise, that's probably fine. Someone gives you one, you tick a box and say, yes, we've got software bill of materials, job done, move on. You're never going to consume it. No one's ever going to use it. That sounds like a waste of time. What we need there to make this work are interoperable standards. We need, ultimately, producers and consumers to agree on what we mean technically about on what a software bill of materials is. And this is the important work that has been going on, I think, for a while, and now suddenly is meeting user demand and user need. There are, I would say, really two clear standards that are probably both going to be, to some extent, widely adopted, at least to start with. One is CycloneDX, which was actually originally sort of not directly spun out, but as a result of work that went on the dependency check project from OWASP. And actually now the CycloneDX project, which was spun out separately and has been a community effort, very much open source centric, has actually now just become a first-class OWASP project. So I think having that banner will help it grow. And there's lots to like about how they're publishing schemas and how the interaction works. Turn up and pull request issues, very much a sort of open source centric sort of development model. SPDX, that you might have come across for its canonical list of license identifiers. But actually, the SBDX project is broader than that. It's about software package data exchange. It's been standardizing in software bill of materials bits for a long time. There is a stable spec that's actually just been going through basically ISO certification. So there's an ISO standard around this now. The new SPDX 3 bit as well solves some of the more, I think, supply chain oriented problems and is looking quite promising, but it's still early. So there's a bunch of history, and so some of the people involved might say these are not emerging, these are in common usage. I think they are in specific places, but not broadly. These are not embedded everywhere, and I think that's what we probably need to see to really get the benefits and see software bill of materials become a thing that actually everyone talks about, or at least doesn't talk about them, maybe uses and benefits even without knowing about it. There are commonalities between these two, which is good. And there are already tools that allow some interop. You could get into arguments about why are there two rather than one. There's an XKCD joke about that somewhere. But there are common elements, and other standards could emerge here that address the same set of common elements. And again, I think there's an interop sort of conversation already. But these are the sorts of things that we're talking about. Okay, where is this? Who gave me this? Where is this from? What is this? Okay, well, yeah, but what version is this? How do I identify this amongst other bits of software? What software does this relate to? You'll know from whatever package management sort of tool chain you're using, there are the dependencies you include, and there are the transitive dependencies that come along for the ride. And maybe transitives of transitives and transitives of transitives of transitives. Like there's a long chain there that the relationship is just as important as the individual bits of software themselves. And who created it and when? And these are the sort of core tenets, I think, core elements of the software bill of materials. Like you can go beyond this. what other information is there about this software that might be useful to the consumer? And again, for both the CycloneDX and SPDX, there are schemas that describe this in JSON. There are some protobuf schemas around. There are XML schemas around. This is actually arguably quite good for something like XML, where there's a lot more richness to the schema declarations, which is a strange thing for me to be saying. So I think there are 3 things about software bill of materials that are worth sort of thinking about when you sort of start considering like how they might play in a software stack. The first one that everyone goes to, and I think too many people stop at, is I need to generate them and then success. And the first bit is you probably do need to generate them. The second one is not true. It's not the end. This is very much the start. There are tools emerging here, both from within the Cyclone and SPDX camps. There's a good set of CycloneDX plugins for different package managers. The Maven one actually is particularly rich. There's a long tail and a maturity problem there, which I'll come back to. And there are other tools as well that have been doing this for a while or are newer, that are also starting to be able to, normally as well as generate things in their own proprietary formats, also output things in standard formats. That's how standards become the de facto. They end up being used by multiple tools that previously just output proprietary formats. And I think you'll see this crop up as an implementation detail of lots of tooling and then get exposed as a first-class interface. So there is work going on here. And I'll come back to some of the, I think, where this needs to go from where it is today there. But certainly if you want to get started today, there are probably some tools that will help you generate SBOMs. But what do you do with them is a far, I guess, more nascent space. How do you store them? Like, if you think of all the software that you're producing and all the versions of software you're producing and all their dependencies, not just in terms of like the package management sort of libraries you're bundling in, but maybe container dependencies, maybe service dependencies, like, and the whole chain of that, it's huge. Like, where do you store them and how do you keep them up to date? And how do you know what the latest versions are? All of those problems become the next problem to solve once you move past, okay, I can generate them, great, what do I do? This is much earlier, though there are a bunch of things going on here that I think are interesting. And this is actually an area of a lot of innovation happening, I would say, around the sort of cloud native communities. Like the BOM repo server is a good example from the CycloneDX folks. I don't think it's specific to Cyclone, but actually it might be. I've played around with this a little bit. It's really a web server that gives you an API for accessing this. That's accessing the SBOMs. A side note there is, I think, maybe a little bit like the work that led from Docker to the OCI specifications. As well as the SBOM specs, we probably need specs that describe access. You've got, in the container world, you've got the registry specification that describes all of that. How do we access and install these things? And you've got the image spec that describes the actual thing. I've not seen much movement there. I think it would be good to see like specifications extracted out of some of the implementations and some standards emerge there as well. But that's maybe getting ahead of ourselves, because realistically, there's not a great solution for storing today. Everyone ends up a bit hand-rolling something. Interesting things here, actually. Shout out to Dan Lorenk, who's working on the SigStore project. He's been doing some work around looking at how do we use OCI registries to store these SBOMs? Because why can't I store it? Like, if I've got a container image, can I store the SBOM with the container image? Well, actually, with the artifact spec in OCI now, yes, you can. And you can even sign those things together with something like cosign. So there's some good early signs of like the tooling here. And I think this is, from a storage layer perspective, a really interesting idea. Like, what if we just said, like, SBOMs, they're just next to the thing that they are representing? In a container world, or using an OCI registry as a distribution mechanism, that's a really powerful idea, I think. But a lot of work to do here. This is a problem you run into, and I think you should not focus too much on generating. There'll be a lot of work there. You'll find something and you get started. This is like, if to make value, I think this is part of it. You need to be able to store and then access and retrieve. Because at the end of the day, that's not the point either. The point is to consume. Like, okay, you've got a load of SBOMs. What are you going to do with them? What value do you get from doing so? You've now spun up some infrastructure. You're now storing something. You've got new steps in your pipeline generating all this stuff. Do you just end up with bits on disk that never get used? That is a reasonable fear. That is something that some people in the broader security community are saying, SBOMs are a bad idea because this is not going to happen. I'm more hopeful. I'm generally the hopeful person. Like, I think this absolutely can happen, but we need to have people thinking about focusing on it and building things and demonstrating examples. There are really strong use cases here, which I think helps. Checking for licenses, checking for vulnerabilities. Again, actually, I work at Sneak. This is what we do. We generate an SBOM and we check for licenses and vulnerability issues. But that's generally been coupled. It's generally been an implementation detail. Suddenly, both are independently valuable. And I think that's an interesting, like, sort of decomposition that we'll see more broadly around, like, some of these spaces. I mentioned I created Contest. I'm a contributor to the Open Policy Agent project when I get time. There's lots of interesting things here around enforcing policy. You can think of an SBOM as a really rich document. Well, I can now write policies against that using Rego. What if I want to, I don't know, prohibit packages from GitHub, or I want to say no to specific licensed NPM packages. That's just a policy decision. I can encode that in Rego. I can put all of my SBOMs through it, and I can surface the violations. So I think there's lots of, like, we have the low-level components there. Actually, fairly straightforward to build singular demos on top of that. What does that look like at scale? I think is interesting. So you can this is a chicken and egg problem. No one really has a large storage of SBOMs in a standardized sort of accessible format to build these things on top of, but it's coming. We need to do all these things. And I sort of feel we'll probably need to do them all in parallel to see the value. If we focus just on generation and then on storage, we'll be so far along that we won't have value and it collapse. I mentioned some other things. I think search here is a really interesting case. Imagine just the ability to really sort of quickly, seamlessly ask questions of your organization's software supply chain, like how many versions of this library are we using? You sort of get this in some places out of some tools, but this is a way of doing it in a decoupled and I think more open way. I think there's a lot of interesting potential to build on top of those types of interfaces. So the last thing is really, okay, if you think this is interesting, then I mentioned the sort of framework documents and the sort of some of the introduction documents earlier. They're definitely a good start to go a bit deeper. If you're like already, okay, I buy this, I want to get hacking, I want to get involved, I think this is an area where there's a huge potential to do so. And I think there are three areas that are interesting. One is client libraries. I think for this to work, we don't need a tool over here that generates an SBOM. We need this to just be built into like how Go does packaging, how Cargo works, how NPM works, how Maven works. Like we need first class like plugins is part of it. Like it has to be upstream in my view for this to be something that really has an industry-wide effect. Otherwise, we're just going to be constantly playing catch up on variations and new versions of those things and generating SBOMs that are not correct. A lot of the early tools around generating SBOMs are going to be good to play around with. They are going to miss things. We need to solve that problem. Otherwise, we're just going to be constantly finding holes in the whole value stream. The other thing is client libraries. The work on SPDX the spec is, again, like there are experts involved there, and I think the spec is coming along for SPDX3, exists for 2. CycloneDX similarly has been evolving really quickly, and there are some like that actually has like really good sort of JSON schemas and protobuf schemas and the XSD definitions. But actually, if you go use any of these things, you need to be someone who goes like, great, JSON schema, I love JSON schema, or fantastic, XSD, I know this backwards. We don't have good, like higher level libraries in nearly any languages at the moment. We don't have type definitions, we don't have classes, we don't have things that really lower the barrier to entry to using these tools. It's schemas. I have a strange history of doing weird things with schemas. Even I don't really I want the client libraries, I want the higher level tools to add things. So if you're a low level sort of client library person, I think there's a bunch of things you can get involved in. And last but not least, I mentioned that this sort of, we need tools to consume SBOMs. Yes, there aren't many out there yet, but building some to see what might be valuable. What's an interesting use case? What do people hook onto? I think these are great opportunities for small focused projects or combining project X with SBOMs to see if something valuable comes out the other side. I think actually we'll see an explosion of talks and little projects over the next year or so that do just this. I think that will be a good sign. Not all of them will be right. Not all of them will work. Not all of them will end up being maintained, but we'll work out collectively what the value is. And some of those I think will become really powerful, interesting, sort of, again, like industry scale open source projects. So with that, I'd like to say thank you for listening. Again, hopefully this is an interesting sort of space to get some people involved. It's a good mix between the sort of standards becoming real world things. I think it's a great opportunity if you want to get involved in a space where there's a bunch of problems to solve. And I think ones that will impact like a wider industry if you get them right, or you end up building the right things. Thank you very much. Any questions, let me know.
Fantastic, thank you, Gareth. That's super interesting. I'm really interested in the whole SBOM world. You know, I spent a lot of time around the embedded space, and I kind of feel like some of those ideas that from the embedded space have sort of moved over into the mainstream now. You know, particularly around traceability. If we look at, I'm thinking of things like Base Rock Linux and stuff like that. That, you know, where it's all about which particular Git commit you could trace every single piece of software back to.
Yeah, I think like the embedded space is often being, it's hardware people, and hardware people have to deal with this already because there are like the costs and economics and the industry as a whole is generally, supply chain is a thing. Software has not been the case. Mm-hmm. And I think we're realizing in hindsight, it sort of has to be.
Well, I think we had one question from the audience for you, which I will just, I've got a couple actually. So the first one was Steve Murray asked, how is this different from a CMDB?
Good question. I think, so I think there's a difference between configuration and the sort of, the what goes into something. I think like that difference is a bit subtle. But I think one is about input. One is about what went into the creation of this. And the other is invariably about sort of much more focused on what's like the actual thing that's running. So again, I think sometimes CMDBs have been stretched or actually have some of these properties. But one of the things I think as well with CMDBs, and some of us have there's similar problems here. Like, do people use the rich data in a CMDB? Like, the problem with CMDBs was that, in my view, is never the theory. And I built some similar sorts of things that I would like on top of the Puppet CMDB, Puppet DB, back when I was a user and at Puppet. But how many people actually have a really successful CMDB story? There is absolutely the same risk around SBOMs. I think SBOMs need to be embedded in software development. CMDBs never were. So, yeah, it's a good rabbit hole to jump down that I won't do now, but good question.
Great, awesome. So I know we have one more question in the Track One Slack channel. Perhaps Gareth might hang out in there for a second afterwards.
Yeah, I will jump over there. Sure.
I've got a question for you, but so over to you, Paula, to introduce our next speaker.